resonance effect, which is uh, this concept of the resonance effect, which is many times of the molecule which is not explained in the one structure. So that's why we are explain these structures, observe their properties of the molecules. We are explain these resonance effect with these three structures which are the given there. In these three structures, you can observe their structure number first, structure number second, and structure number third. So these are the benzene structure and these three possible structures which are the given there. Now, out of all these three structure, which structure which is the correct structure? And we are doing study here a resonance effect regarding to the benzene ring. So in that you can observe there is a 1, 2, 3, 4, 5, 6. So these are the positions which are given there. In second structure 1, 2, 3, 4, 5, 6. So these are the uh, possible numbering which is given there. Same numbering, but you can observe there in between 1 and 2. In first structure there is a double bond, but in the second structure at 1 and 2 there is a single bond. So that means this is the difference in between structure number first and structure number second. Also you can observe there in first structure at carbon number 1 and 2 there is a single bond, but in structure number 2, carbon number 1 and 2 there is a double bond. Also which is happening in case of the carbon number 3, 4, there is a double bond, there is a single bond. At 4, 5, double bond, single bond. At 5, 6, there is a single bond, there is a double bond. So these are the two different structures which are given there. At carbon, at one pair of the carbon there is a double bond in structure first, but at second carbon there is a another bonds which are the present there. There is also third one possible structure which is given there. There is a cyclic structure which is given there, and at cyclic structure there is a dotted circle which is indicated there. So these are the three possible structure which are given there. Now out of all these three structure, which structure which is a correct structure? So out of three structure, you can there are some important things which are given there. Generally, carbon carbon bond, which is a single bond which should be having bond length which is a 1.54 angstrom unit, while in case of the carbon double bond which is having close to the 1.34 angstrom unit. That means एखाद्या ठिकाणी जर सिंगल बॉन्ड असेल तर तिथे किती बॉन्ड लेंथ असते 1.54 angstrom unit. But if there is a double bond, then that bond length which is a decreases to the 1.34. Single bond, that is a 1.54, and double bond, that is a 1.34. That means single bond which is a longer bond and double bond which is a shorter bond as compared to the single bond. But what happen in these all these structures? As per this concept which is given there, double bond that means bond length short, single bond that means bond length long, also which is in case of the structure number first. But experimentally we can observe there all carbon bond length which are the in benzene, these are the equal. That means all bonds in this structure, these are the equal, there is no change in the bond length. So that's why which is given there, that is the 1.39 angstrom unit, which is in between this 1.54 and 1.34. That means which is not double bond, which is not single bond, which is the this bond length which is in between single bond and double bond. That means all carbon bonds which are the equal, which are the given there. That means structure number 3 which is the correct here. Okay, structure number 3 which is the correct here. So this structure number 3, all bond lengths which are the equal. Why? Because of the resonance effect. Resonance effect which is the responsible here for the all bond lengths which are the equal in the benzene. And all these bond lengths which are the equal, because of that this structure which is known as the hybrid structure. आपण ह्या स्ट्रक्चरला काय म्हणत असतो ते hybrid structure. Why hybrid structure? Because all bond lengths, whatever double bond or single bond, all bond lengths these are the equal, and these structure which are known as the hybrid structure, and this phenomena which is known as the resonance. Okay, that means the resonant structure we can better explain here with all these three examples. Okay, let me share here. Okay, this is the resonance effect which is given there. In the resonance effect, there are some examples which are given there. In first one example, you can observe there is a double bond, there is a positive sign. That means in resonance structure, what happen? This double bond, this double bond which is a okay, this double bond which is a double bond which convert into the single bond with donation of the electrons to the पॉझिटिव्ह चार्ज मीन्स इथले जे डबल बॉन्डचे जे इलेक्ट्रॉन्स असणार आहेत ह्या सिंगल बॉन्डला डोनेट होणार आहेत आणि काय असणार आहे पॉझिटिव्ह चार्ज जनरेट होणार आहे सो दॅट इज द रेझोनन्स मीन्स migration of the electron from the one bond to the another bond, that is the meaning of the resonance. You can observe in this structure also. In this structure, this carbon CH3 and this CH, so this hydrogen which donates electron to the this positive charge carbon, that means which is a deficient carbon, and after donation of the electrons there is a generation of the positive charge here. Okay, so there is a generation of the positive charge which is the shown in the second number structure, but that is not happen here, which is a correct way. First one which is a correct way. Okay, migration of the electron from the double bond to the single bond, double bond to the single bond, but there is a this is an incorrect way. Why? Because electrons always migrate from the double bond to the single bond. So there are two structures which are given there. Out of these two structure, first structure which is the correct here. Okay, that means always double bond which donates electron to the deficient carbon, and there is a generation of the double bond. Simultaneously there is a generation of the positive charge. Okay, त्याच वेळेस काय झाला इथं पॉझिटिव्ह चार्ज हा जनरेट झालेला आहे. In 6.1 point which is given there, equivalent structures of the benzene which are given there. In equivalent structure of the benzene, you can observe there is a shifting of the double bond inside of the benzene. You can observe there this double bond which shift to this carbon which is indicated in the structure. Simultaneously this double bond which shift to the this single bond, that means single bond which convert into the double bond in another structure. There is also double bond, but in the second structure there is a change of this double bond, that means shifting of the double bond which is given there, that is the resonance. That means single bond which converted to the double bond and double bond converted to the single bond. So this is a happen in these two structure. And third one structure, that is a equivalent structure, that means all bonds these are the equal in the structure number 3. Okay, seventh one structure which is given there, you can observe there is a double bond. Okay, so in between this carbon there is a double bond. So migration of the electron from the double bond to the single bond. So इतर बॉन्ड शिफ्ट झाला लगेच सायमल्टेनियसली हा वीक अनस्टेबल होतो आणि हा काय असतो इलेक्ट्रॉन्स डोनेट टू द लास्ट वन कार्बन. So that is the resonating structure which is given there in this structure. So इथं arrow which start from which carbon there is generation of the positive charge, and end at which carbon there is generation of the negative charge. Negative charge means which is having electrons. Positive charge, that means which is a deficient with electrons. So next one structure you can observe there. So in the next one structure, what happen? This double bond which is given there, you can also write down here, that is a negative charge and positive charge alternatively also. Okay, so there is a positive charge, there is negative charge, there is positive charge, there is negative charge. So both of these structures which are the similar structure, you can also write down there after breaking of this double bond in that what happened in the double bond. Let me clear here. So this double bond which donates electron to the this one carbon, so which this positive charge also which donates electron to the this double bond, that means there is generation of the double bond, or after generation of the double bond there is a which is indicated here plus minus sign, but double bond generation, single bond, and there is a double bond. Okay, means काय होतं बघा इथे पॉझिटिव्ह चार्ज निगेटिव्ह चार्ज, means we can shift here positive and negative charge in between the carbons. Next one structure which is also given there, in the next one structure, negative charge means which is rich with electrons and which donates electron to a single bond, double bond generation, and this double bond which convert to the single bond. So there is a negative charge which is generated here, because electrons which are the migrated on the oxygen. काय झाले बघा याच्यामध्ये, इथं सिंगल बॉन्ड होता, इथं काय झालं, इथे डबल बॉन्ड झाला, इथे डबल बॉन्ड होता, इथं काय झाला, हा सिंगल बॉन्ड झाला. मीन्स हा निगेटिव्ह चार्ज कुठे शिफ्ट झालाय, ऑन द ऑक्सिजन. हा शिफ्ट कशामुळे झालाय, बिकॉज ऑफ द मुवमेंट ऑफ द इलेक्ट्रॉन्स. Next one, structure which contain distorted bond angle which is given there. Distorted bond angle, bond length which is a less stable which is given there. Structure number second, you can observe there structure number second which is a more longer than normal CH bond. So that's why which is a less stable. That means longer bond length. This structure which is having one carbon number 1 and carbon number 4 which is having longer bond length, so that's why this is the unstable structure, and carbon this structure number first which is a more stable structure regarding to the resonance effect. Next effect which is given there, that is a hyperconjugation. Now what is the hyperconjugation? So this is the hyperconjugation. In the hyperconjugation which is given there, hyperconjugation which is a modification of the resonance effect, that is a mesomaric effect, and it is a permanent effect which is observed even at the ground state of the molecule, and it influences physical and chemical property of the molecules. Resonance and mesomeric effect which is the involved delocalization of the pi bonds and non-bonding electrons, where hyperconjugation effect which involved delocalization of the uh, sigma electrons. Sigma electron delocalization which is given there. What is the difference between hyperconjugation and resonance effect? In resonance effect, there is a delocalization of the pi bonds and non-bonding electrons, while in case of the hyperconjugation, there is a delocalization of the sigma electrons. So that is the difference which is given there. Already we are seeing there are alkyl groups which are the electron donating groups, and these electron donating groups which is the magnitude of the inductive effects. So this is the inductive effect which is given there. There are 3 CH3 group, tertiary butyl group, isopropyl group. There are 2 methyl group. Next one, that is the ethyl group. Last one, that is the methyl group. That means number of the donating groups which are the increases. Inductive effect that also increases which is given there. Hyperconjugation effect which also affect on that. If alkyl group which is attached to the double bond in order to the found to be exactly opposite, that is the changes behavior which is explained by the hyperconjugation. Delocation of the sigma electrons of the sigma H bond which is a takes place which is shown here. That means at carbon number, this is a double bond, and next to the carbon bond that is a sigma bond, sigma carbon which is given there, and this is a sigma bond. Sigma bond which donates electron with the this CH bond, there is a formation of the double bond which is given in the second structure. Simultaneously, this double bond which converted to single bond with donation of the electron to the this one carbon. Okay, you can observe there is a minus sign. Minus sign indicates there is one extra electron which is present to the this carbon. So this is about the there is a breaking of this bond which is adjacent to the double bond. So this is adjacent to the double bond. We can also break another these two carbon this hydrogen bond also. Any one hydrogen bond we can break here and convert to the double bond here. So there is a plus H plus which is given there. That means hydrogen which donates electron for the formation of the double bond and which generate positive charge here, and simultaneously there is a negative charge which is generated in the terminal carbon which is a negative charge. So as like this way we can adjust here hyperconjugation, or we can write there hyperconjugation with the number of the structures also. Next one, that is the toluene which is given there. In toluene this is the carbon, and next to the carbon that is the alpha carbon, and this alpha carbon which is having alpha sigma bonds. All these are the alpha sigma bonds. So all these alpha sigma bonds, any one hydrogen which donates electron for formation of the double bond here and which form positive charge. Simultaneously, there is a generation of the double bond. Double bond, that means this double bond which is unstable, which convert to the single bond. You can observe there. That means migration of